A pilot flying at an altitude of 2.7 kilometers sights two control towers directly in front of her. Okay, so y'all are going to make fun of me the way I draw an airplane. There's our airplane. Here are all the windows. Okay, whatever. That's an airplane. And there are two control towers directly in front of her. So those control towers are on the ground. So here's the ground. Here's one control tower, and here's another one. So the angle of depression to the base of Tower A is 37 degrees. The angle of depression to the base of Tower B is 58 degrees. So we actually don't know just by looking at this picture which of these two towers is Control Tower A and which one's Control Tower B. So we have to think about the size of that angle of depression. So there's my line of sight down to one of them and my horizontal line. So here's the first angle of depression. Then here's my line of sight to the base of the second control tower. So here's the angle of depression. So the question we have to ask ourselves is, which angle of depression is larger? Is this pink angle of depression larger than the orange one? Yes. So the pink angle of depression has to be the 58 degree angle. The orange angle of depression, which is smaller, has to be the 37 degree angle of depression. And so that will help us determine which one is Control Tower A and which one's Control Tower B. So this is Control Tower B and this is Control Tower A. We're trying to find the distance between the two towers. So we have this right triangle and our pilot is flying at an altitude of 2.7 kilometers. So our airplane is 2.7 kilometers above the ground. That's what the altitude means. It's above the distance above the ground. So I'm just going to slide that over here. And so now I'm going to find this distance, A. So I'm going to redraw that triangle over here. This is 37 degrees. This is 2.7. And this is A. So if this is my right triangle and I'm trying to find A, this is my opposite side. This is my adjacent side. And so if I think about SOHCAHTOA, I'm going to use tangent. Tangent relates the opposite and the adjacent side. So tangent of 37 is equal to the opposite side, 2.7, over the adjacent side. So then I'm just going to multiply both sides by A. A times tangent of 37 is equal to 2.7, and then I need to divide by tangent of 37 on both sides. And so now I'm going to do 2.7 divided by tangent of 37, and I get A is 3.583. Make sure you're in degree mode or else you're going to get wackadoodle answers. Okay, so back to the problem. This up here is now this up here is now 3.583. Okay, now here's our second right triangle. This is still 2.7, but now we're looking for this distance, B. So I'm going to redraw that triangle. The angle of depression was 58 degrees. So I'm still going to use tangent because this is my opposite and this is my adjacent. So tangent of 58 is going to be opposite over adjacent equals 2.7 over B. Going to multiply both sides by B to get it out of the denominator. B times tangent of 58 equals 2.7. So I'm going to divide both sides by tangent at 58. They cancel out. And so then I go type that in my calculator, making sure I'm in degree mode. And I get 1.687. Which is good because just looking at my picture, that needs to be smaller. So had it not been smaller, that would have been problematic. So if this whole distance is 3.853, this distance right here, this distance is 1.687. I want to figure out what's the distance between tower A and tower B. I'm going to need to subtract 1.687 from 3.583, and I'm going to get 1.895, and it says let's round that to the nearest tenth. So rounded to the nearest tenth, our final answer is going to be 1.9, and this unit, the units are kilometers. So sometimes you're going to have two triangles, two right triangles, and you're going to have to find maybe the distance between them, or like sometimes they're going to be maybe something like this, where like you're going to add the two bases together. Just multi-step angle of elevation and depression problems.